So you want to learn to balance redox reactions in acidic solution. Well, that's actually a pretty fun thing to do. And in this video, I'm going to walk through 3 examples of using our half reaction method to balance redox reactions. The nice thing about balancing redox reactions is there is a defined protocol for how to go through and do what we call the half reaction method. And it's always the same. We always do the same set of steps for every reaction. There's really no deviation from the process. So here are the steps as they appear in your textbook. You can add these to your notes. But as we go through our 3 examples, I'm just going to kind of talk through each of these step by step. And yeah, that's how we balance redox reactions. So here is our first example. So when I start balancing a redox reaction, the first thing I need to figure out is what is oxidized and what is reduced. And the way that I'll do that is I'll assign oxidation states, and then I'll see how those oxidation states change. So I'm going to put the oxidation states on each of our elements. So there are our oxidation states. So now that we have those applied, we can see that copper goes from an oxidation state of 0 to an oxidation state of +2. That is an oxidizing or an oxidation process. And then nitrogen's reduced. It goes from a +5 to a +2. So being able to figure out what was oxidized and what is reduced allows me to do the first step of our protocol, which is split this big reaction here into what we call half reactions. So I'm going to do the reduction half reaction and the oxidation half reaction. So there are the 2 half reactions. So again, we identified nitrogen as being reduced from a +5 to a +2. So I pull out the compound that nitrogen's in, which is the NO3, and then the compound that it ends up in the products, which is NO, and that's my reduction half reaction. I do the same thing for the oxidation process. This is copper to copper 2+. So I just pull those out and I put them in their own half reaction. Notice I am also bringing the charges down for these things, but I don't have to include the states because the states aren't actually going to affect anything. So the idea is that we're going to balance these 2 half reactions independently, and then we're going to add them together at the end, and that gives us our full reaction. So 2 halves make a whole. So I'm going to balance the reduction half reaction first, and then we'll do the same steps for the oxidation half reaction. Okay, so the first step in our balancing process is we want to balance all the elements that aren't oxygen or hydrogen. So in this case, we're only looking at the nitrogens, and my nitrogens are already balanced, so I don't have to worry about that. The second step is we're going to balance oxygen by adding water. So over here on the left side, I've got 3 oxygens, and on the right side, I've only got 1 oxygen. So if I add 2 waters to the right side, that gives me a total of 3 oxygens. 1 here, and then 2 from the water. Now, if I add waters, I'm also adding hydrogens. So then our next step is we're going to balance hydrogen by adding hydrogen ions. So we're going to come over here and we're going to add 4 hydrogen ions for the 4 hydrogens in the water here. And this is happening in acidic solution, so these hydrogen ions are just around. They're just about, and they're going to participate in this reaction. Same thing with the water. This is happening in aqueous solution, so there's just water around, to do the thing in the reaction. Okay, so I've balanced stuff that's not oxygen and hydrogen, then I balance the oxygen, and then I balance the hydrogen. And we sort of go in that order, in that process. All right, now for the tricky part. I have to balance the charge on either side of the equation. So I have to think about the total charge. So in this case, I've got 4 hydrogen cations here. So 4 hydrogen ions. Each one of those has a +1 charge. So that means that the total charge from that stuff is +4. I've got one nitrate. That nitrate has a -1 charge. So +4 plus a -1 gives me a total of +3 on my reactant side. And then over here on the product side, all of this is uncharged. So the total there is just 0. So neutral charge on the product side. So the way that I balance my charges is I add electrons, and the electrons are always going to go to the more positively charged side. So in this case, we've got a side that has a charge of +3. That's more positively charged than our side with a charge of 0. So I'm going to add 3 electrons to my left side, because now that gives me a charge of -3 plus the +4 plus the -1, and that makes the overall charge 0. And so now I've got the same charge on both sides. I think this is by far the trickiest thing to do because it's really easy to miss a charge. So in the next examples, we'll kind of see some more difficult iterations of that. What I will say is the charge doesn't have to be 0 in each side. It just has to be the same. And so sometimes it's 0, sometimes it's some other number. But as long as the charge on the left is the same as on the right, then we're good to go. Okay, we're going to hop down to our oxidation half reaction. We're going to do the same set of steps. Okay, let's go in the same order. So balance everything that's not oxygen or hydrogen. So 1 copper, 1 copper. We're done with that. Balance the oxygens. I don't have any oxygens to balance, so we're done with that. Balance the hydrogens. I don't have any hydrogens to balance, so we're done with that. So even though I'm not doing those steps, I'm still going through the checklist. So again, we have this protocol, we have this checklist, and we just always do the steps. And there's no deviation from that. Okay, so now we balance the charges. The charge on our left side is 0, because that copper doesn't have a charge. The charge on our right side is +2. Again, our electrons are going to go to the more positive side, so that's our +2 side. And if I add 2 electrons over there, that makes both sides have no charge. Again, it won't always be 0 on both sides. It's just the example that I've picked here, just as long as they're the same. Okay, charges are balanced. All right, so we are almost ready to add these 2 half reactions together, but we have to do something really important before we do that. The number of electrons in each half reaction has to be the same before we can combine them. So I've got 3 electrons in my reduction, 2 electrons in my oxidation. I want to think about doing least common multiples. Least common multiples. So for 2 and 3, the least common multiple is 6. So that means that I'm going to multiply everything in my reduction half reaction by 2. That will give me 6 electrons up there. And then I'm going to multiply everything in my oxidation half reaction by 3. And that'll give me 6 electrons down there. And once I've done that, then I can add them together. So I'm going to pause the video, go through, and make those changes. Again, that's going to go all the way through to everything because we want the ratio to stay the same. We're just scaling it up. And then we'll come back, we'll add these things together. All right, so we've got our 2 half reactions, each with 6 electrons. And so now we're ready to add them together. Adding them together is as simple as everything that's on the left side of both equations just goes on the left side of our total equation, and everything on the right side just goes on the right side. And then we're going to cancel out things that are the same. The only thing that's the same in this example are our electrons, and so we just don't include those in our overall reaction. All right, and there is our overall equation. We could check it and make sure that it's balanced. 3 coppers, 3 coppers, 8 hydrogens, 8 hydrogens, 6 oxygens, 2 oxygens here, and then 4 more there is 6, 2 nitrogens and 2 nitrogens. So I think we did it. All right, so we're going to hop over. We're going to do one that's got a few more kind of moving pieces to it. It's the same set of steps. It's just there's a couple more things we got to manage. Yeah, and then we can do an even spicier one after that. Okay, here's our next reaction. This one's going to have a few other things that we have to kind of manage. Namely, we're going to add water and hydrogen in both half reactions, so we don't get off easy like we did on the first one. But to kick us off, to get us started, I'm going to go through, I'm going to put oxidation states in, and then we're going to decide what is oxidized and what is reduced. All right, so here's what we got. In this case, we've got a bunch of stuff that's not changing, namely all these oxygens and hydrogens are staying the same. But carbon goes from a -2 to a 0. That's an oxidation process. So this will be our oxidation half reaction. And then the chromium goes from a +6 to a +3. That's our reduction. So now we're able to see our two half reactions. We'll get this broken up and we'll start balancing. All right, so here are our two half reactions. Again, we're just going to go through the same set of steps. We'll start with the reduction half reaction. So first we got to balance everything that's not oxygen or hydrogen. I've got two chromiums here on the left, but only one chromium there on the right. So we're going to put a 2 in front of that. That gets everything balanced before we start going. All right, we're going to balance the oxygens by adding water. So I'm going to add 7 H2O to the right for those 7 oxygens. And then we're going to balance the hydrogens that I added by doing 14 H+. One thing that I will say about the redox stuff is the coefficients tend to get pretty big. Usually in chemistry, we don't deal with stuff that's like a 14 or, sometimes you'll get like a 24 kind of thing. In redox, that tends to happen. Okay, we got all that done. Now we got to do the hard part, which is the charges. So 14 hydrogens, that's a +14 plus a -2. So that's a total of +12 there on the left. And then over here on the right, we've got 2 times the +3. So that's a +6 total. The water is not charged. All right, so +12 total on the left, +6 on the right. We're going to add our electrons to the more positive side. So they're going on the left side over here, and we're going to add 6 electrons. Because those 6 electrons are going to bring this total charge down to +6, right? So now we've got -6 plus 14, which is +8, -2, +6. So electrons are bringing the charge down because they have a negative charge. So this is a good example of how it doesn't end up being 0, right? It just has to be the same. So in this case, it's +6 on each side. All right. So I think we're good with that one. We're going to hop down. We're going to do the same for the oxidation half reaction. Okay, so same set of steps. We're going to start by balancing everything not carbon or hydrogen, not oxygen or hydrogen, which is only the carbons. They're already balanced, so we're good to go there. Now we're going to balance the oxygens. Oxygens are also good to go. We got 1 and 1, so that's fine. And now we're going to balance hydrogen. I've got a total of 4 hydrogens here on the left, but only 2 on the right. So we're just going to add in 2 hydrogen ions like that. And then we can go on and we can balance charges. Charge here is 0 because that is uncharged, and the charge here is +2 because we got 2 hydrogen cations. Again, the electrons are going to go to the more positively charged side, which is going to be over here. And in this case, I'm just going to add 2 electrons to get both sides down to 0. So let's add those 2 electrons in. Right, so now that makes our total charge here equals 0, right? Because now we got the -2 and the +2. Okay, so we've balanced that half reaction. Now we do need to add these together, but just like in the last one, we got to make sure that our electrons are the same before we do that. Luckily this time, I only got to change one of my half reactions, and that's the one here on the bottom. I got 2 electrons. I'm just going to multiply everything by 3 so I can get it to 6. So we'll do that real quick. So 3 CH3OH, 3 CH2O, 6 H plus, and 6 electrons. And now that our electrons are the same, we can add these together. All right, so I brought these a little closer together so that we've got some space to work with. I'm going to do the same thing I did last time. I'm just going to put everything that's on the left of my overall, and everything that's on the right of the overall equation, and then we'll talk about canceling stuff out. I think the biggest challenge with this is making sure you have enough space, which I totally ran out of space here. Okay, so we get to cancel out things that are the same on both sides. You will always cancel out your electrons because those are always going to be the same, so we get to do that. But in our last example, we didn't cancel anything else out. And this time we have something else we can cancel out. I got 14 H pluses on the left and 6 on the right. So that gives me a net of 8 on the left. So I want to subtract out the 6 that are on the products. Sometimes we will also do that with the water. In this case, we don't have any water on the left to do that, but that's kind of the other thing that gets kind of thrown in here. Okay, so now that I've canceled out those hydrogen ions, right? So getting rid of the 6 that end up in the products and give me a net of 8 in the reactants. I'm just going to rewrite it just so it's a little bit neater. I still ran out of room, but we got it done there. I like to put the states in the final answer. I usually don't do the states through the half reactions just to save myself a little bit of work. But there's our overall balanced equation. Again, same process as before, just a couple of things to kind of clean up at the end. So we're going to do one more example, and in this last example, there's even more cleanup to be done. I think that's sort of what makes it more challenging. So we're going to hop over, we'll do one more, and we'll talk through that one. All right, here we go. One more balancing redox example. So same set of steps. We're going to first go through and we're going to do oxidation states so we can figure out what's oxidized and what is reduced. All right, so it looks like manganese, Mn, is reduced from a +7 to a +2, and then our nitrogen is oxidized from a +3 to a +5. So that's going to allow me to split this up into reduction and oxidation, and then we'll get to balancing. Okay, there's our 2 half reactions. Let's do the same set of steps. So we'll start with the reduction. I don't know why I always do the reduction half reaction first. It actually doesn't matter which one you do first, but anyway, balance everything not oxygen or hydrogen. So just the manganese, those are already balanced. Then we're going to balance the oxygens by adding water. So we're going to add 4 H2O for the 4 oxygens. That adds 8 hydrogens, so then I come back to the left, add 8 hydrogens, and now we get to do the charge. All right, 8 hydrogens. That's 8 plus the -1 from the permanganate, that's this MnO4, that's the permanganate anion. So that's a total of +7. And then over here on the right, it's +2 plus 0, so that's a total of +2. So again, electrons go to the more positive side, so they're going here on the left. You'll notice through all 3 of these examples, they always go on the left or the reactant side of the reduction reaction. That's not a coincidence. That's actually what redox is. And then they go on the product side of the oxidation. So you might notice that trend too. You can think about it that way if it's helpful. But I always say more positive side because it's easier to remember. So if I add 5 electrons over here, then that is going to give me a total charge of +2 on both sides. and that balances my charges out. Again, another good example of how it doesn't have to be 0, it just has to be the same. Okay, we like that. All right, let's hop down, let's do the oxidation one. Okay, we're going to start by balancing the nitrogens. Those are balanced. Then we're going to balance the oxygens. So we got to add 1 water here to the left, just like that. Then we're going to balance the hydrogens. So we're going to add 2 H plus to the right. And then we can go in and we can do the charge. So here on the left, all of this actually has no charge. So it's all 0. And then here on the right, we've got a -1 from the nitrate plus a +2 from our 2 hydrogens. So that gives me a total charge of +1. So again, electrons are going to go to the more positive side. That's the right side. And you'll notice in our examples that it's always the right side of the oxidation. And we're just adding 1 electron there. That's going to give us a neutral charge on both sides of this half reaction. Okay, so now we're about ready to add these together, but before we do that, we got to make sure our electron number is the same. I got 1 electron down here and 5 up there. That means I got to multiply everything by 5 in my oxidation half reaction so we can get those electron numbers to be the same. So I'm going to pause the video and take care of that. All right, so now our electrons are the same. We got 5 there and 5 there. We're ready to add these two things together. So again, there's more cleanup to be done here. This time we're going to do it kind of as we go versus like doing it all after we add it together. I just want to kind of show you that that is also a possibility. So we know that our electrons cancel out. That's good. We've got 8 hydrogens here and 10 hydrogens down there. That's going to give us a net of 2H plus here on the right. And then we can also do the same thing with our waters. We got 4 waters up there, 5 down here. That's going to give us a net of just 1 H2O down there. I'll just put the coefficient of 1 in front of it. So we can kind of do that canceling before we add it together. And then we bring everything down. I forgot to mark out my 8 hydrogens. So then it's just MnO4, put the state there, plus H2O plus 5HNO2 gives us Mn2 plus 5NO3 minus plus 2H plus, like that. Let's put an aqueous there. Okay, so the cleanup can happen before you add it together or after you add it together. In either case, that's what you'll end up with following the half reaction steps. All right, I hope that was helpful. Thanks for watching.